Welcome to Pondering AI. I'm your host, Kimberly Nevela. In this episode, it is a pure pleasure to be joined by Maximilian Vogel. Maximilian is the co-founder of Big Picture, where he focuses on AI strategy and Agentic AI. He joins us today to talk about what Agentic AI is in its current instantiation and what is the work required to make it work. So thank you for joining us, Maximilian.
Thank you for the invitation. Great to be here.
Now, before we wade hip deep into the topic of Agentic AI, I noticed that some of your educational background was in philosophy and information sciences. And I was wondering what it was about those domains that initially sparked your curiosity and presumably started you down the path to your work today.
Yeah, actually, in philosophy, we talked a lot on AI that days, which a little bit past now, but it was from a completely different perspective. It was the so-called body-mind problem, which came up with AI. Can a being which is not a human, which doesn't have a real mind, a real soul, as the philosophers stated, that can that really think? Can it even feel, or does it have a consciousness and things like that? That's the way from philosophy. From information science, it's basically the term data science didn't really exist at that time in academics. It was more like data science. It was really structuring data and doing that with the first tools in AI and things like that. And that brought me a little bit on the path.
So it sounds like you've always had a bit of a natural predilection for this particular area of study and application.
Yeah.
And it strikes me that combination of factors in education also stands you very well, not just to address the technical aspects of AI and Agentic AI, but also to talk a little bit about the human factors. So why don't we just we'll get right to it then. So I'd like to start with just laying a little bit of a foundation about what it is that we mean by Agentic AI. So for you, what is it that distinguishes an agentic system from a non-agentic system? Or I suppose the other way to ask that is, what are the characteristics of an agentic system?
Yeah, basically modern agentic systems all are built on generative AI. So the basis is similar or basically the same. But what differentiates them is that agentic systems are able to do a multi-step processing, which usually models at the beginning weren't able to do. There are some things now which are built into the models to help them to do a little bit of more than one step and build conversations within a session based on the previous turns. But things like processing, maybe for instance an insurance claim, that's one thing we did over hours, days, weeks, and maybe even months, requires an agentic system which can completely keep the context and do a lot of processing steps, which may not entirely be based on generative AI, but often on deterministic processes as well. So that's the key differentiation.
Is it true that alone large language model does not an agentic system make?
No.
There's more componentry required, correct?
No. You usually need more components. So the big vendors build components, agentic components into their, at least into their chat interfaces. But just a model, a generative model, an LLM, for instance, or even LRM is not by definition not an agentic system.
And why is that not? Because we certainly think, or a lot of people are talking about it. I suppose a little bit tongue-in-cheek, I would say you can't sort of prompt your way into an agentic system. So why is it really important for people to understand that it is a component and not the whole?
Yeah, basically, it can be made to an agentic system by, for instance, adding tools like being able to perform a web search or calling MCP tools or something, a model context protocol, tools like these. What really differentiates it usually can't do the next step in a process on its own based on a classification, on a decision. So it lacks what an agent should have: agency. Basically, the ability to decide, I have this data, now I should do this and hand it over to that process, and then this other process goes on forward. So this is usually something which is not already built into the model platforms, and which is not part of the core models like GPT-5 or so from the scratch. It is built into some of the chat interfaces now, a little bit of agency, but yeah, it's not a real agent. If I tell him process these complex things based on this data, usually it will stop and come back to me and will not resolve the case end to end.
Mm-hmm. And I want to talk about the work required to make sure that we're applying Agentic AI to the right problems and to problems that we're confident it can solve, and also how do we get to the high levels of accuracy. But what you're saying there speaks to something, or a frustration we hear a lot with organizations, where it seems like you can prototype things very, very quickly, but getting the system into production. And I think what you've said is the core of the issue, which is it's easy to sort of mock it up, if you will, even just with a sort of standalone LLM or foundational model. But in fact, and maybe it's the agentic system, that system is the important word, that these are in fact engineered workflows, correct? Yeah. These are engineered systems, and in a very real sense, they require the same level of rigor, development, thought as any other non-AI-based system. Is that right?
Yeah, absolutely. Usually you have to build around the models, you have to build around sort of a deterministic process, taking the answers of the models, then getting data from databases based on the extracted data from the models, like, for instance, a customer identification number, then coming back with the record, giving it back to the next model session, trying to get the data which is needed out of that, and then going on with the processing. And usually you need a lot of algorithms around it to really make it work.
Mm-hmm. And I think there's also, there's probably a number of, I'm going to call them aspirational statements. There are also probably assumptions that are incorrect or just not true when we think about developing these systems. And one of them is around this idea of what it means to be confident in the system. And you have said that confidence doesn't come from a model. A model can't determine confidence. Confidence has to come from the humans in defining and describing the system, identifying the problems. So can you talk about, where people get I don't want to say it's wrong or are misled when they think about confidence, and how you actually approach this question of confidence in the system?
It's super complex. Basically, so the background to this confidence thing is, if you're, for instance, talking to ChatGPT, it will almost answer any question. And that's nice in the direct interaction with you, because you can see, okay, no, maybe that's leading in the wrong direction. But if there is an autonomous agent which really must run on its own, which must be reliable, safe, secure, you need some point where the model says, okay, don't know based on the data. I can't take a decision. I can't process this. I can't extract the data. I'm not giving you some proxy data or so, but I should hand over to a human colleague who maybe has other means to look into this problem. So at our first step into agentic processes, we thought, we just ask the model if it's confident or if it wants to hand over. It almost never wanted to hand over. It's It was always confident. Yeah, that's a question. That's a question I can answer. Yeah, no, it's not a problem. Maybe, but you have to look on it. But that's not the thing we wanted to have. What we wanted to have is basically one number. We boiled it down to a floating point number between 0 and 1. What is your confidence? 100% confidence, 0, no confidence at all, I don't know. And this was surprisingly hard to get it trained into the models, because usually they are confident. The answer they give is usually the answer with the highest log props, with the highest probability of tokens pushed out. And so yes, they are confident, and we have to build it. We had to build it into the models into another way, and use a lot of training data. For instance, if you get multiple IDs, multiple customer IDs, multiple tracking IDs, social security IDs, also in the mail of a customer, don't just pick one or the first or the one most often appearing, but tell us, I can't really find the one number you are looking for where we could look up the record in the database, but there are more than one number, and maybe I should not be confident on that, and put my confidence lower. And so we trained that models to a confidence. Here in this case, for instance, if there are multiple numbers and you should just get one, your confidence that you pick the right number must be lower, must be something at 60% or 0.6 or 0.4 or something like that. And that was hard. The models bring a lot of confidence on everything they say, and to bring them back into a mode where they just say, I don't know, was not easy.
Does it? When you are trying to assess, then, is there a role in that processing stream, or in that workflow, if you will, then for first the human team to say these are sort of the rules for what confidence looks like or not, right? In a very deterministic way, which means that to some sense it's not really the model, if we're talking about an LLM in this case, and the models you're talking about here might be other components which might not be LLMs, right? Yeah. To say that, in this case, for instance, there's more than one answer that was returned, and therefore I need to go down a different flow.
It's actually when we build an agentic solution, we usually build it with the business experts or domain experts who are working with that. And the first question is always, what would you do? So what would you do when you get something like this? And then they would say, oh, yeah, that's complicated. Yeah, maybe we have to look multiple records up, or we write back to the sender of the email, hey, please send us one number so we can look up your record. Otherwise, it would be complicated. We can't process multiple records. And if they say something like that, we say, okay, then this should not be a process. It's maybe the 1% case. It's the 0.5% case in the process cases, and this should not be one thing. We train the model to really do it. This should be handed over to a human team, to a real domain expert, and here the confidence of the model should be low. So it all comes from humans. All the processes and how to cope with this outliers comes from humans, basically, from definition of the domain experts.
Mm-hmm. And we might assume that if we think about what makes a good problem for an agentic system, that it has to be a workflow that all the instances or the cases or the events can be 100% processed by the agentic workflow. But what you're saying there, and also I think what I understood in your article, was that that's actually really not the case. You have a different threshold or a different way of thinking about that. Can you talk about that?
Yeah, at the beginning, we thought a little bit like that. If we can't fully solve 100% of the problems, maybe we should do another case. But we didn't identify these cases completely without outliers. Usually, that's things where people already put things into web forms, into fields, and select drop downs. And then why would you need a model? Then maybe you could completely process it by algorithms. But if you have free text and people are writing things, scanning documents, putting attachments, it's usually you can't really completely foresee what is coming into such a process. So humans on the other side, so everything basically could come. So we switched to basically a business case where we say we want to process 70% or 80% or something like that in that dimension, fully automated, which means from the first email to the closing of the process, and maybe 20% or 25 or 10 or something like that can be handed over to a human operator. Still, this would be a great case for automation. And if you take something like that, you can even automate the work of complete and a little bit complex departments where you don't get rid of the human team, but hand them over the real complex things, often the cases which have a higher business value. For instance, in many cases of business, it's even the cases which have a higher monetary value. For instance, insurance cases where the house was completely destroyed or something like that. You wouldn't process that by the model because there are many documents and photographs and things as that. But we could help the team if we process the cases where something was destroyed in the value of $300 or $400 and then help them to focus on the high value cases.
Mm-hmm. So what else do you look for to determine whether a certain problem or processing flow is a good candidate for agentic AI or automation? And what are the characteristics that you would say, it's not even just, I can, that would have you say, like, this is not a good place for us to spend our time or effort or to address with agentic AI?
Yeah, the first thing is because we do a lot of testing and evaluation, we usually pick cases where our business partner tells us we can clearly say whether something has been processed correctly or not. For instance, this can be in logistics. Did a package arrive in healthcare? Is this the correct diagnosis or not? It's super hard in some cases in marketing. Is this a good copy? Maybe not. Maybe it's a little bit generic. Maybe it's on overdrive. That's not the way we communicate, but it's still good and something like that. If you're not able to determine whether the processing was correct, it's super hard to get better, to do the evaluation and then in the end implement it in a successful way. So we focus on not on the unicorn use cases where the model does something magic, but on the mule use cases where the model does some work reliably and safe and secure and things like that. That's easier to implement. And then another thing is the number of cases. That's super important. If you have something, I wouldn't automate things because they are complex to build. If it's something like 10 cases, 20 cases, 100 cases, usually look beyond 200, 500 cases a month, then it's worthwhile to really automate it.
And again, I think that goes back to what's a little bit of an underlying thread in the whole conversation, which is there is germane effort, development time, business time required to develop these. And so you want to make sure, as in anything else, right? This is not the unicorn, agentic AI will go and figure it out for you scenario that we sometimes hear about.
Yeah.
Mm-hmm. You mentioned getting to an accuracy, and can we talk a little bit more about what it might take and maybe just some examples of how you both ensure, like I think one example you had driven the error rate from like 5% to 0.05%, right? So this is a very, very low tolerance for errors. And what were some of the steps and the mechanisms you used to do that? Because I do think that sometimes we also have an overconfidence, not to overuse that word, but in even the ability of something like, we can just use something like RAG, or we're going to just, improve our prompts and we're going to be hallucination free. And hallucinations and accuracy are not always the same thing. But what are some of the sort of concrete things so people have a sense of the types of mechanisms required here?
Yeah, basically one thing is, and still I did a lot of prompt engineering in the past, but still it was surprising as well. For me, it's prompt engineering. It's really building the prompt and tinkering with the text in the prompt and trying it out and let it run through the evaluation set. One thing is really prompt engineering, and the prompts really get very long, but the state-of-the-art models, they are able to process really long prompts. But that helped us a lot to add a lot of cases, and often we are getting better in integrating cases which were mal-processed before, where we see, okay, this was processed not correctly. Why not? Is it reproducible? Maybe we have to change the prompt. This is a new thing we didn't foresee. We have to bring it into the prompt. So it's really prompt engineering, and super interesting. And it's a little bit hard to do it on a high level because there are not many prompt engineers out there. So if somebody with a computer science degree hears that, our podcast really, if you work yourself into prompt engineering, this is needed. It's hard, and you need really good prompt engineers on that. On the other side, we had a few tricks, but you had a question on prompt engineering, or?
Oh no, well, I was actually interested in when we talk about sort of prompt engineering, I don't know if maybe it's the mindset or the proclivity, right? The way the scientist or an engineer thinks are often a little bit different in how they approach the problem. And so I'm interested in when you are thinking about the idea of a prompt engineer, is this more the profile of what we might think of as a traditional data science or data analyst, or is this someone with more of a traditional engineering bent, if you will, or is it some combination thereof? Hopefully not a magical combination thereof, but
maybe a magical combination is not required. Often I prefer people from the with data science background, or who ventured into data science, because often for the guys from the engineering department, the problem is solved if it works 3 times. Yeah, and
I don't know what engineers you're hanging out with, but I think I might be hanging out with different ones.
Maybe once. Yeah, it works on my computer. But for the data scientists, they know, okay, they really have to run it against large sets of data points, and then get the numbers out, and then know whether it works or not. And this approach, it's really a little bit. The prompt engineering is a little bit of data science, a little bit of engineering as well. It's a little bit of black arts as well, because some things work and you don't know exactly why they do work, but they do work, and you still keep them in your prompts. But data science is usually good. But I've quite a couple of engineers who work into this field as well, and that work as well.
And, back to that question of accuracy in addressing things like hallucinations, because I think as we both well know, hallucinations really are a feature and not necessarily a bug of a large language model. And so one of the examples I had come across, and I think it actually was perhaps in your article, that I thought was really interesting was that although you were using, and I think this was in response, right, to craft a response to a customer, maybe it was an insurance claim or not, I don't remember it explicitly, that they would, you kind of go through this process. And so there were a bunch of models and things in that workflow that would identify what the object was, figure out what the value was, figure out what that, and then maybe use the LLM to generate sort of the written response for the client, but that you then took that response and checked it against a validated list of responses, which in theory, I think then allows you to avoid this issue, for instance, like with Delta, where we had someone say, no, yes, we absolutely will refund, or that situation where somebody managed to get a $1 deal on a very, expensive car. It did beg the question, or it could beg the question, I suppose, of like, well, why then why do you need the LLM in that, that restaurant, if you still have to go to that sort of set list anyway? And I think this is one of the interesting.
It's a super interesting question. The thing is, you can talk almost any model, even the best models, in granting you a refund if you're smart enough. Because of this late package, my grandmother died, and I think I'm going to sue you. But if you grant me this upgrade or something like that, at one point or the other, the model, if you hit the right tone, get the right message, they will give in. And it's super hard and requires a lot of and a lot of engineering to avoid that. So our way was, there is no such thing as a refund message, except in one case where we have a classification and so on, a processing, and we see that, and there is a refund message, and there is a defined refund which we can give to the client. And they will never be able to talk us into a refund. This will just be ignored. So we have defined messages a model can give out, and the magic we get from the model, or we borrow from the model, and what the algorithm processes can't do is basically first the classification, to do a really correct classification. And the classification is never something like the customer is really in great need and now needs a lot of money from our side immediately. But the classification is this is justified because it's case 7. We lost a package, or we didn't, the flight was not in time, and things like that. And if this classification is correct, quite a couple of text templates the model then can choose based on a classification, or even an algorithm can choose based on a classification. And the extracted data of the models are being filled in. And the thing is, when we talk to departments on the customer side, we don't work in our daily work. We are software developers, scientists, and so on. We don't work like this. But on the customer side, in their departments, they work with these text templates as well. For instance, when you get a message about a refund, about grants, or something like all things involving money, usually not somebody types an email to you, but they're using predefined text and fill in the data. And for them, that was supernatural and absolutely no problem. And if you're going into the finance area, like insurance or banking, usually they prefer everybody to use these templates, because they are sure on the legal side there's nothing the employee could write which maybe could construct something where they go to the lawyer and tell them, we can sue them, they wrote this and that. But everything is vetted and checked, and they prefer using something like that. For the mule jobs, basically, you can only do that for the mule jobs. For the unicorn jobs, it would make no sense at all.
Yeah, and those are the unicorn jobs that you actually wouldn't.
We're not doing
right.
that.
You wouldn't recommend going down this path anyway. But again, I think what's really interesting there is that work required to define what are those cases discretely, and also what are there's a bounded set of responses. Which again, when we think about LLMs, sort of out in the wild, there's a proclivity to think like, oh, well, the great thing about this is all of these can be sort of customized responses. Well, that's really not what we're trying to achieve here, right? This goes back to the point is safe, secure, fully automated, highly accurate processing.
Yeah, absolutely.
Now, I guess maybe to that point too, you also really encourage folks in identifying what problems to solve, and then what success looks like with an agentic system to, just like, again, any other developed engineered system, to focus on KPIs versus features. Yeah. Can you talk a little bit about why that's important and what you even mean by that, and why, what dangerous areas you can get into if you're not careful about this distinction?
One standard way in going into software development is that the client usually delivers something like a specification, gets to the service provider and or a vendor and says, okay, this is our specification. Please implement that. We want to have this implemented. You can do that with AI as well, but it can be a super complicated and cumbersome process, both for the client and for the service provider, because you mostly 80% of the work that's a standard is working on the outliers, on the special cases and things like that. So we turned the thing around and told our clients, and they were really happy to accept that. Basically, that's not what you want to do. You don't want to implement a process like specified, but you want to save something, maybe save time or process more and do a little bit of automation. Let's just do an agreement on KPIs, something like 80% processed fully automated, and from this 80%, 99.5 or 99% processed correctly. That's basically something they have in their human teams as well. They make errors, write wrong emails, mix up data and things like that as well in some of the cases, and do something like that. And then we identified many cases, clustered them to greater cases, and said, okay, if we add up these 12 cases or something like that, it's more than 80% automated processing, and let's focus on that. And everything else is going into the manual bucket, that's processed manually. And of this 85% we selected, even 5% or 7% will go during processing into the manual bucket as well, because the confidence gets lower at one point, and the model says, okay, let's give that to a human.
So you've been working and actually truly developing and deploying agentic systems. Again, as currently defined, I think folks will quibble about because these are obviously not systems that are creating their own objectives and deciding what to go work for, right? That is actually decided for them. But that quibble with the original definition aside, what if are there any other kind of key lessons learned or recommendations you would give to folks, that you've developed or that relate to things that you hear people saying, out in the wild, if you will, that will not serve them well in going down this path?
Some things you really, or one thing you really need is data. Data not in the form that everything must be cleaned up before you build up the agentic system, we usually work on live data. So if the client write us mails in this or that form, we take that. If the guys from the warehouse, from the finance department or so on write us mails in this or that way, we take them and have to process them. So we're working on live data, but we need evaluation data. So from a set of live data, we take evaluation data and where we can say, here, this is processed correctly. Here, this is not processed correctly. Here, this assessment is being done, or the classification is being done correctly. Here, it's not being done correctly. And you need a lot of data. If you don't have the data, at any time you have to go back to the client again. Is this correct? Is this not correct? Or something like that. And you can't test for yourself. So that's one thing which helped us a lot. And maybe for other service providers, what helped us to bring the process live, we usually put the process live at a client in a way that we have something like a 3-month period where nothing leaves the company, no money, no letter, no email or nothing without a human in the loop. So we usually have a 3-month period of human in the loop. We offer that to them, and a mechanism, a website where they can look on the process, look on the results, and then say, okay, fine, that's going out or not. And this is helping, I'm using it again, helping to build confidence on the client side, that the process really works and that they really have it in their hand, and they don't install a system and then have a major shitstorms because hundreds of their clients are complaining, we get this email, this is completely wrong or something like that. And in this phase, we still can learn. Usually we go from accuracy then from maybe 97% to 99%, because we identify in a real productive system, we identify other cases which we didn't see in the test system, which we then can optimize or correct. That's another thing.
Well, and I think that's actually a really important point, because it speaks to a point of, it's a sort of a deployment phase, transition phase.
Yeah.
That I imagine, as you said, provides you the opportunity to ensure that the rules and the boundaries that you've designed and defined are in fact working.
Yeah.
But also humans are innately creative in the way that, I imagine no matter how much test data and scenarios pulled together, someone, like myself, who's just particularly stubborn about things, right, will get in there and perturb the system in some way, just because you sort of refuse to give up. And let's be honest, sometimes customer service processes are do not favor the those who are not prepared to invest some time and energy. But that aside, but there's also then, that's actually really shouldn't sort of be seen as the traditional post deployment. We're just going to monitor, the traditional software sense. This is actually still an active development, testing phase, right? Which means the way that you resource the project and the levels of support are very different. And it still does not negate the need to do that very, very thoroughly in the previous phase. So it's additional. It's an additional phase, I would say, to what we think of as the traditional
it's
SDLC.
It's basically an additional phase. And here our model for this process is a little bit human teamwork and human operations as well. So if you bring a trainee into your team, for instance, you may not let them answer if it's a financial service provider or something like that. You may not let them answer client mails at the first day, but at the first days they have to give it to their supervisor, and then if the supervisor gets confident and says, "Hey, good man, good woman, they are really doing a great job, then they will give you the allowance to directly answer the client emails or whatever. And it's a little bit formed after the human process. Maybe that's one thing we maybe another point. We think of the agent system not so much as a software system, but as a new colleague or a team of colleagues supporting the rest of the team. So usually we build that they communicate with the other team members via tickets or emails or something like that, not via some weird interfaces where you have to log in and go there, but they're communicating with the rest of the team with the same means as the team members do as well. When they're communicating with each other, that makes it easy to integrate into the process and quite easy to supervise as well, because there are supervision structures in every application we usually these customers of us work with, and that's a little bit of a model which helped us greatly to bring it into the organization.
Mm-hmm. Now I could, and perhaps in another episode would quibble perhaps a little bit with the characterization of it as a colleague or a teammate, because I think there's other considerations there. But what I do take from that and agree is what you're saying is that the interface of what we think as the system outputs, maybe it used to be in the old days, it used to be an error log, right? Or it was a report. Yeah. Now the interface, the outputs here and what gets put back is in the same format, whether it's an email or a chat or something, right? So it's that interface is in that natural language in using the same sort of forms it would have been if it was as you do with your human colleagues.
And there's nothing in the way the agent does, not unlike other software systems where the human person sits before and says, oh, I can do anything, the system decided this or that. They can take the case, do it their way, and say, yeah, no, that's wrong, how you did it. Like it's more like a counterpart than an IT system they communicate with. And that's helping. Usually the humans are much smarter and much better in the business processes. So usually the way it goes is from the system to the human, say, please help me.
Yeah. I think the language gets tricky, and as I said, I take issue. I tend to take issue with it more because I think that when we talk about systems as colleagues or people, there are implicit assumptions people then make about capability, about capacity, about even agency, funnily enough, that then I think lead us down paths, and it's, the old conversations about over-reliance and also all of those kind of things. But that's a conversation I think for a whole nother day, because it's a whole nother conversation. But I think it's a good point though about thinking about what the interaction model is between that system and the humans in the loop. And so, because this is Pondering AI and we always want to do that, I would love to touch just a little bit on your observations of that people factor. There are quite a few, as you've said, aspects to that. But we are fairly unapologetically here talking about being able to automate, right, 80% of certain processing flows, which certainly has some impact one way or the other on people's jobs. So how do you think about that? And do you see a difference in how people react or respond to that, for instance, in Europe versus on this side of the pond where I am in the US? Is there a difference in attitude about that?
Yeah, so the first thing is when we install the system to at least interface to the people more like colleagues, one problem does not arise, which you usually have to with other IT systems, that the humans have to learn into something. They don't. So they do their same job. They just focus. That's the only thing. Their job gets much more complex because they really can do only the complex cases, because the easy cases are done by the system. So usually the remaining people on the job are quite happy because they get a little bit of an upgrade in their work, which is even an upgrade financially because they're more like in a supervision position, and that's helped them. That helps them. But still, basically, very often the rationale on doing that is paying less wages. To get part of the team. Of the department, maybe in other departments, and things like that. And it's a problem. It's an open question. I thought when until a few days ago, when this MIT study arose, that it's really already making an impact into hiring and layoffs, but they say no. Not really, if you look at all the numbers, but maybe it will. For instance, into this junior jobs where people doing easy repetitive jobs to get into the work, to learn the work. This is clearly endangered, and this is clear, and we have to talk about it. I don't have a solution for that. I think in the history of automation, the people went into new jobs, but there is this question, clearly. So basically, what we have seen, the teams in Europe, they sort of appreciated it really because they got other jobs in the company, which are a little bit more demanding, and usually in most European companies you have something like a job guarantee that you are not losing your position. Might be quite different in the US, where they say, okay, basically now we don't need you anymore, but still this is an issue. And in Europe it will translate into, I think, into fewer hirings then. So they will not employ the same amount of people. If they're doing automation, it will translate in fewer hirings, and this still is an issue. There's youth unemployment and things like that.
Yeah, so something I think we are all going to have to grapple with and address somehow, and certainly not in the tongue-in-cheek, well, now you'll just have time to do the things that, give you bliss. But there's also an interesting point there that you were talking about, because you are working to develop these systems in close conjunction to the people who use them, to the employees themselves, right? Which is so they actually now have the opportunity to work on more interesting or more complicated cases. However, they have likely developed their expertise to be able to do that by cutting their teeth on those simpler cases. And we really are going to have to think about how do you actually develop that. And that's obviously a broader open question across lots and lots of domains and lots of areas, which is there's a ladder there that we've taken a few of the lower rungs out, and what is that going to look like? But as I said, a conversation for another day, I'm sure. But I appreciate very much that even as you are doing your work, that you and your company are also, thinking and cognizant about that. So all of that being said, as you look at the work you've been doing with developing truly and productionalizing truly agentic systems, and the broader conversation, any sort of final thoughts or things you'd like to leave with the audience before we go?
Maybe the only thing, it's one thing we already mentioned is really focus on the dull jobs. It's not fancy stuff. It's not usually if you've seen the presentation of OpenAI on GPT-5, it's all the fancy stuff. What can the model do? I write a few lines of code and it builds a learning application for my girlfriend to learn French or something like that with a mini game integrated. Bullshit. Basically, it's nice. It's nice. It's playful and I like it. I like to watch it and things like that. But if you're a company, they too often focused on things like that, not anymore, but in Europe there were people who were really trying in larger enterprises to build a digital twin of the CEO. Oh no, focus on adult jobs, and focus on accuracy, reliability, security, safety, and then you will not be part of the 95% of the MIT study who fail, but of the maybe 5% who really make an impact on your business. Yeah, last word, long last word.
I think it's very important, and a wise and well seasoned from someone who is actually deploying these systems and deploying them at scale, which is still, despite the publicity, very rare. So I think everyone would be well served to listen to that insight. And I really just want to thank you so much for coming on today and sharing your experiences and those lessons learned really from the trenches.
Thank you very much. Yeah.
Awesome. And if you'd like to continue learning from thinkers, doers, and advocates such as Maximilian, you can subscribe to Pondering AI now. You'll find us wherever you listen to podcasts and also on YouTube.